Hello and welcome to Pep Talk with me, Mr. Pepperell. Today I'm thinking about what do we actually mean when we say that something is efficient. By the end of this episode you should be able to tell me what do I mean by efficiency and what can I do to make a machine more efficient. So you've probably heard the term efficiency before, but what does it actually mean? Well, efficiency is actually a measure of how much of the energy that's transferred by a machine is actually transferred usefully. Now, just to remind ourselves at this stage, energy is actually measured in something called joules, given the letter capital J there. Now, 1 joule is actually the amount of energy it takes me to raise 1 Newton weight, and 1 Newtons is 100 grams, is the energy it takes to raise that 1 Newton weight 1 metre into the air. Okay, so raising 1 Newton, a distance of 1 metre from the floor, takes 1 joule of energy. Now, if I actually did this, I'd be transferring chemical energy that's stored in my body into kinetic energy as I actually lifted the weight up, and as the weight got higher, it'd be gaining gravitational potential energy. But in reality, my muscles would also get a bit warm. They'd get hot as I carried out that bit of activity, lifting that weight over that distance, okay? What would happen here is some of my stored chemical energy would be wasted, okay? Now, here's the thing. If I know how much energy I actually use, how much of my chemical energy was actually used, and how much of that energy was actually transferred usefully to this weight, I can actually work out how efficient my muscles are. And here is the equation that I use to calculate that efficiency. So, to calculate the efficiency of my muscles or any other machine, I simply divide the energy that's been usefully transferred, divide that by the total energy supplied, and then I multiply that number by 100 there to give me a percentage efficiency. Okay, so let's see if we can have a little look at this in action. So I've got a light bulb here which I'm supplying with 200 joules of electrical energy. Okay, now that light bulb transfers 160 joules of that energy to light, so I can see not all of the energy I put in is coming out usefully, okay, but I can use the figures I've got to work out the efficiency of the light bulb, okay, because all I need to do here is I take my useful energy, which in this case was the light, and I put it on top of my equation. So useful energy divided by the total energy supplied, and I put that down the bottom there. Now 160 divided by 200 is 0.8, but I multiply my answer by 100 to give me a percentage efficiency, which in this case was 80% efficient. So now it's your turn to try and do the math, okay? My question says a winch is supplied with 300 joules of electrical energy. Now, the weight that the winch lifts gains 200 joules of gravitational potential energy. And the question asks us, how efficient is the winch motor? Well, pause this now, have a little go in your book there, and then start again, and we'll work through it and see if we get the same answer. Hopefully you've paused it, hopefully you've had a little go at working that out. Well, let's see what answer we've got here, see if we've both got the same thing. Well, all I've done is, firstly, I've taken my usefully transferred energy, which is the amount of gravitational potential that the weight gained, and I've put that on the top of my equation there, so I've got 200. I've taken my total energy supplied, 300 joules, and I've stuck it on the bottom, so I've done 200 divided by 300. I've multiplied my answer by 100 to give me a percentage, and it's given me an answer of 66.7% efficient. Now, in the exam, okay, I'm getting marks for showing this working as well, so don't just put your answer down. I mean, that was probably 66.66666 on your calculator. I've rounded it to 66.7% there, but you've got to remember to show this working to get the full marks in the exam. So here is my winch, and we know it's not really that efficient. It was actually wasting 33% of the electrical energy I put in. So what can I do to prevent this and make my winch more efficient? Well, firstly, I can cut down on friction in the moving parts. So the moving parts inside the motor there, I can lubricate those parts with oil. It cuts down on friction and stops me wasting energy as heat. I can also tighten up all my little nuts and bolts and make sure there's no rattly parts on there to prevent any of my electrical energy being transferred to wasted sound. There's no point, the winch doesn't work, better, it doesn't lift the weight in any more effective way just because it makes a rattly sound. Okay, I could also use wires inside my motor with a low electrical resistance to stop heat being lost that way.
Okay, now we're looking at a winch here, but if it was a different type of machine, like a car for example, I could make the car more aerodynamic to stop it losing energy as heat due to the fact that parts of the car drag and cause air resistance. Okay, now although it's important to make machines as efficient as possible, no machine could ever be greater than 100% efficient, because that would mean you were getting more energy out than you're actually putting in the first place. So no machine is ever going to be greater than 100% efficient, but the closer to 100% efficiency you get, the better for you, because the energy you put in is being put to good use.
So that's everything we need to know for this episode of Pep Talk on efficiency, how to calculate it and how to increase the efficiency of a machine. Any problems with that, don't hesitate to tweet me at Mr_Pepperell or email me and I'll get back to you ASAP. Thanks for stopping by.